All right, the second video, we're going to delve a little bit deeper into what vectors are. One of the next definitions is on scalar multiplication. So a scalar is just some sort of constant where we can multiply it by a vector and it's going to do what you would assume. So if this k, this multiple is 2, what it's going to do is it's going to double the size of the vector v. If it's instead 0.5 or 1/2, it's going to reduce it by 1/2 of whatever its length was. The only other thing to note here is if we have a negative value for our scalar, it's just going to flip the vector in the opposite direction. So, for example here, say this is v. If I took 2v, it would just be the same direction, only double. All right, and 1/2 v would be same direction, only about half the distance instead. Or if I took a negative v as well, so let's do that. Blue, negative v. It's going to look the same as the original v does, only it's going to be going in that direction instead. That's how the scalars work. Okay, so we can add or subtract vectors, or if we can add a negative vector, which is equivalent to subtracting. And when we do add vectors, what we're going to get is we take the direction of one vector. So if our v goes in this particular direction, that's our v, and we have another vector w, and again this is w up here. Then the resulting vector is this reddish line here, going in that direction. So basically what you do is you're going to make some sort of square, parallelogram, that sort of thing, rectangle, and you're going to get the hypotenuse if you're adding the vectors. Now, if you're subtracting the vectors, it looks more like what we have over here. Okay? So we take our vector v and then our vector w, and this side instead is how we would graph that, and looking for the actual vector of v minus our w. And it should be, again, similar in nature to if we were just adding a negative. We get the same result, the same corresponding vector. Excuse me. And one last thing, this guy down here, this is called, this is the triangle inequality. You've just noticed above here, we're making triangles when we're trying to calculate what they are. So this notation here, if you recall, this is the magnitude. So this is the magnitude of the vector v plus w is less than or equal to the magnitude of the vector v plus the magnitude of vector w. In fact, we get equality only when the vectors have the same direction. So that's the only way we're going to get equality. Typically, you're going to see it's going to be less than what that is.